Next, we will discuss the Simpsons 3x rule in part 4 as another alternative approach to approximate the integral of a function. Simpsons 3x rule is an extension of Simpsons 1/3 rule, where the integrand is approximated by a third-order polynomial rather than a quadratic polynomial. Hence, 4 points of 3 segments are needed to fit into the cubic interpolating polynomial. More precisely, the integrand is displaced by the third-order Newton's divided difference polynomial as follows. Here, a is the x0, 2a plus b over 3 is the x1, that is the second point. Then a plus 2b over 3 is the third point, the x2, and b is the end point. Then the coefficients b0, b1, b2, and b3 of the third-order Newton's divided difference polynomial are given as follows. After integrations and algebraic manipulations, we obtain this equation in its simplest form. This equation is called the Simpsons 3x rule because h is multiplied by 3 over 8. Now, let's look at how to use Simpsons 3x rule to approximate this integral. First, let's determine the value of h. Since the region under the graph is split into 3 segments, for cubic interpolations, the integration interval is divided by 3. The step size is then equal to 0.2667. The 4 points we have here are this. Now, substitute this point into the integrand. We will get this value. Finally, if we put these values into the formula of Simpsons 3x rules, the approximations turns out to be 1.6634. As usual, a better approximation can be achieved if final segmentation is done for Simpsons 3x rule. However, just take note that the integrations interval has to be divided by 3m segments always for composite Simpsons 3x rule due to the approximations made in Simpsons 3x rule is based upon third-order interpolations. Simpsons 3x rule is applied to each 3 segments. Total integral can be written as this. Adding up the integrals over every 3 segments will provide an approximation for the integrals over the entire interval. In general, the composite Simpsons 3x rule has the following form. Okay, let's look at the example for the case where n equal to 6 segments for Simpsons 3x rule. First, we will find the value of h by dividing the integrations intervals by 6. Then, we will substitute the resulting 7 point into the integrand, so these are the corresponding values that we will get. Now, let's substitute this value into the formulas of composite Simpsons 3x rule, and this will be our answer. We know that the exact answer is 1.5663. Comparing the exact answer with the approximations obtained via Simpsons 3x rule, we notice that the approximations getting much closer when we have more segments or smaller value of h.